Some of the government's most important websites are crashing when we need them the most. More than 22 million people have filed for unemployment in the last month, an unprecedented number, driven by the global coronavirus outbreak. Now, Congress has put aside an extra $250 billion to handle the new applicants, but as people go to the state-level systems to file, a lot of those websites are just timing out.
Some say that applying for unemployment benefits is nearly impossible.
The state computer system is having some trouble.
They need to fix the website.
This isn't how the internet usually works. Services like Netflix and Zoom have seen a huge surge in traffic too, but aside from a few hiccups, you'd never know the difference. Most web engineers plan to be able to handle 10 times the regular traffic without breaking a sweat. But government systems don't work that way, and it's surprisingly hard to shift them over. A lot of that's because of the back-end programming, most of which is written in a coding language called COBOL that dates all the way back to the 50s. But to understand why they're still using COBOL and why it's such a problem, you have to see how these sites were originally built. And most importantly, you have to look at the big picture. The story of COBOL starts in 1959, way before personal computers or the internet. A corporation or university might have a computer network, but you were really only going to run programs within your specific system. So each network developed slightly different rules, and it became really hard to transfer programs or data from one network to another. So a group of engineers, including legendary Navy programmer Grace Hopper, started working on a common programming language that could bridge those networks and be the main language for businesses going forward. They called it the Common Business-Oriented Language, or COBOL. By the 70s, COBOL was the standard. If you were managing a huge database system, you wrote all your code in COBOL. And that dominance is a big part of why it's still in use today.
This is by no means a dead language. It's something that certainly millions, possibly billions of financial transactions rely on COBOL on a daily basis.
If you want to switch off COBOL, you basically have to start from scratch, so a lot of people just stuck with it. It also locked you into a particular kind of server architecture. Running COBOL code meant you were running everything off a handful of servers on your internal network. When it was developed, that was the only option, and even later there were real advantages to it. You could teach your server special tricks for handling your specific kind of data, and deploy programs to the whole network without having to install them on every specific machine. But it was also putting a lot of weight on that one server. If that server goes down, the whole network goes down. And if you try to bring in a replacement, you'll need to teach it all those special tricks. But when the internet happened, you suddenly had to worry about keeping your service running in the face of huge shifts in usage and constant code updates. That meant treating your servers in a completely different way. As engineers started to put it, they're not pets anymore. Now they're cattle. When you've got 50 servers running, it doesn't matter if one of them goes down. You just bring in another one. And you make sure they're all so dumb and interchangeable that you can cycle them in and out without anyone noticing. You don't train them, you just herd them. And because these are global web services, that also means you can distribute your herd all around the world, scaling up or down depending on how many people are visiting the site that morning. With cloud hosts like Amazon Web Services or Microsoft Azure, you don't even need to buy a whole server. You can just rent 1% of a server for a few hours just to make it through that morning's spike in demand. Name any online service that's launched in the last 20 years. They basically all work on the cattle model. That means lots of basically disposable servers cycling in and out. But a lot of these state unemployment systems have been running continuously for 40 years, processing thousands of applications every week, all on COBOL. They never switched over to disposable servers, which makes it hard to process the kind of traffic surge that YouTube or Netflix would take in stride. It's not that COBOL is a bad programming language, but it locks you into a bad way of managing your network. It forces you to treat your servers like pets, and because switching off of COBOL is so much work, a lot of government systems have never been able to make the leap to the cattle model.
It's incredibly difficult to even find workers who know COBOL. The language is old, and some of the people still fluent in it are even older, with many approaching retirement age. This has become a recipe for disaster in states that still operate under COBOL. Governors like New Jersey's Phil Murphy have called for programmers to come out of retirement to help maintain their overwhelmed systems.
You can't really move a COBOL program to the AWS cloud, so it just sits there getting older and a little harder to maintain each year. Programmers call this technical debt, and if you aren't spending money on upgrades every year, it piles up fast.
For more than 10 years, the federal government has been pressuring state Medicaid programs to update their aging systems. They've been handing them large sums of money to modernize, but it's still an enormous lift.
Before these folks retired, many of them had been fired. They'd been laid off, and then they'd actually been brought back in crisis moments to fix and upgrade the COBOL systems, which, ideally, they should have just been kept on to maintain the entire time.
The real problem is we just haven't been spending money maintaining these systems. We haven't wanted to, or we thought we could skate by without it. And then when millions of people suddenly need unemployment checks, the entire system is buried in technical debt. It's a hard lesson, but if we want the reliability that we expect from web services, we're going to have to pay for it. Thanks for watching. If you want to know more about COBOL and this whole saga, my colleague McKenna Kelly wrote a great article in the description. And let us know in the comments if there's anything else you think we should be covering.